Alright guys, today we're looking at factoring expressions that have a GCF. Now, this is not the same, exactly the same I should say, as what we were doing last chapter when I told you to simply factor out the GCF. This is just the first step in a longer factoring problem. Okay, so you're doing the same thing as you were then, but then what you have to do is you need to check to make sure no other factoring can be done. Okay, the big key here is that this is the first step in any factoring problem. This is always what you should check for first, is the GCF. The reason you need to check for that first as opposed to waiting is because it makes your problem easier. Okay, plus you might see something that doesn't look like it's factorable and then you take out the GCF and all of a sudden it is again. Okay, so this is the first step in any factoring problem, is the GCF. Okay, so we're not learning anything new. We're just saying check for a GCF, factor it out if possible, then try to factor what's left. Okay, so the first one, GCF, 2, 16, and 30 all divide by 2. They don't all have variables, but they all are divisible by 2, so my GCF is 2. I'm going to write that outside parentheses, and inside parentheses I need to write what's left, meaning whatever I put in there, if I multiplied by 2, should get back to my original expression. Really, you're just dividing everything by 2. So we get x squared plus 8x plus 15. Now, you have to check what's left in parentheses. Is that factorable? If it's not, you're done. Okay, and you're done factoring. This is still considered factoring. Okay, like you wouldn't write prime if an expression had a greatest common factor. But we should check to see if x squared plus 8x plus 15 is factorable. And it is, because we can find two numbers that multiply to 15 and add to 8. Those are 5 and 3. So we can write that as x plus 5 times x plus 3. Simple, right? That's really all there is to it. Now, if you had forgotten to take out the GCF at the beginning, I kind of want to just show you what would have happened. You still would have tried to factor this, but you would have tried probably splitting the middle term or brute force method or something like that. Let's say that you tried splitting the middle term. So you would have done 2 times 30 is 60, and you would have been looking for two numbers that multiply to 60 and add to 16. Well, the most obvious thing I can think of that multiplies to 60 is 10 and 6, and those do add to 16. So let's see what happens now. You get 2x squared plus 10x plus 6x plus 30. Factor out some GCFs. 2x here, 6 here. And you do get matching parentheses, which is nice. So you've got 2x plus 6 times x plus 5. Now here's a problem that we have. Your answers don't match, right? The answer in the green doesn't match the answer in the blue. But they should, because anytime you factor an expression, you should always get the same answer. Otherwise, you probably haven't factored it completely or you did something wrong. The issue is that we still have a GCF. It's right here. See, since both of these numbers divide by 6, we can factor out a GCF of 2 just from that binomial. We don't have to worry about the other binomial because that's separate. Okay, so we can still factor out that GCF of 2 from here and rewrite that expression as 2 times x plus 3, and then leave that in x plus 5. Now, our answers match. So even if you forget to take out a GCF, and you end up doing the problem a longer way, you should still check for a GCF at the end, because that way you can kind of make up for any mistakes you might have made by missing it at the beginning. Okay, but try your best to just look for that at the beginning. It makes your life so much easier. Okay, try the next one on your own. I'll give you a second to do that, pause, and then come back. In fact, you know what? Go ahead and just try every last one on this page. Try everything up through D. Pause, and then come back when you're all done. Try them all. Okay, so this first one has GCF of 2. Okay, and this is one that's very similar to what we were just doing with x's and y's. Okay, but there's still no coefficient before the x squared, so we can still factor this using the short way. So looking for two numbers that multiply to 12 and add to 7, that's 4 and 3. So that's going to be x plus 4y and x plus 3y. Leave our 2 out front. There we go. We're done. Again, much easier, much easier than splitting the middle term. Here, our GCF is 2x squared, or 2x cubed, sorry. What we're left with is x squared plus 3x minus 4. Hey, another nice shortcut one. So we're looking for two numbers that multiply to negative 4 and add to 3. That's plus 4 and minus 3. So we get x plus 4, I'm sorry, and minus 1 times x minus 1. One more left. Here, we're not going to get a nice shortcut one. Our GCF is 2x to the 4th. We can't quite take out a 4. So we're left with 2x squared plus 9x plus 4. I'm going to factor this by brute force method. The reason I like brute force for this one especially is because I know I've got a 2x and an x, and I've got two plus signs. Okay, so I just have to figure out what goes where. I could try 2 and 2, but I kind of know this one. It's going to be 4 there and 1 in the with the 2. Go ahead and check it out if you want. You get 2x squared, 8x, 1x, there's your 9x, plus 4. And then just leave your 2x to the 4th out front. So that's it. Make sure this is your first step in any factoring problem, because there are some that you actually won't be able to factor at all unless you factor out the GCF. You can still catch it at the end in some cases, but it's much easier to get it at the beginning.